This session is led by Teddy, who I think is getting his slides ready. But you'll be doing some kind of hands-on sensor kit design. This is sort of what you'll be doing. We're going to be passing these around.
So I'm going to take you on an hands-on, and I would like your attention because it's a bit technical, and most people, those who have some good physics in them, they can still use the same items in air quality data collection. So I'm Teddy Mwendo from Kenyatta University. We have a good program that we are doing with Columbia University. So we have a facility where we do data collection, which is Kenyatta Columbia University Data Center. So we have 3 grid reference monitors, and we have about 4 locus sensors. We have 2 RAMs, and we have Quantoc AQ monitor, and we also have a TOM, we have a NOx, we have ozone. Oh, you can't hear me? Okay. We also have ozone analyzer, and we have NOx analyzer. I think that passed you. So I'm going to take you through on Arduino and the accessories whereby they are integrated or interfaced, or they are connected to Arduino. And we are going to check what is Arduino. Okay, Arduino. Arduino, it's an open software. In your boards, you'll a green board or a blue board. You will have an Arduino or ESP8266, which is a 82.0. This one, you have it? You don't have? Do you have a ESP8266? Some have a, that's an original Arduino. You have it? This is more of a small computer. What you use with it, you program it. Yes, you program it, but that is a bit advanced. All those who are having a ESP8266, it's a bit advanced. It has a provisional of Wi-Fi, and we are going to check on it. So Arduino, it's an open source software, inexpensive and open source hardware. Easy to use for beginners, easy to write and debug code. It works in Mac, Windows, and Windows. So generally you can use Arduino in your laptop. It's very easy to upload the code, how to write the code, what you write to the code, how to use the code, what communication do you pass to the code, how do you approach the Arduino, on how many items you are going to interface on Arduino. So let's check how many types of Arduino do we have. We have Arduino Uno, we have Arduino Nano, we have Arduino Leonardo, we have Arduino Micro, we have Arduino Nano Every, we have Arduino Nano 33 BLE, we have Arduino Nano 33 BLE Sense, we have Arduino MKR0. So on all these types of Arduino that we have, each Arduino is unique on its own. It has specs which do not have the other Arduino, or has the same specs but an advanced specs from each to each other. So what you have on the containers, it is a ESP8266 D1, which is a wireless 802.11, which is a very good device. It's it has a microcontroller, so we are going to check on the parts on the ESP8266 on D1. The most popular ESP8266 is the small one. We're going to check if we have one, and we share. So Wi-Fi, it has a provision of Wi-Fi module into a fully fledged development board. So this is the most common Arduino product you're going to find in the market. It's very common, it's very fair, the cost is very effective, and it's very nice. So let's go and check on the points. So this is a power point to power the board, and this one is a USB port whereby you need to provide the coding and connect to your laptop, and we'll do a small demo on it, and then we're going to do that connection. So we have a reset button. Whenever you're using a serial monitor, you need a reset button to check on the communication, or if the Arduino has lost any communication. So on this end, we have a digital from the grounding all the way to 0. All that is that's a digital output. And on my left, we have some few ports that are commonly used to power the interface items. We're going to check the most essential parts. So if there's a part you'll really use, is a serial clock and the serial data. And we have a serial clock, and also we have a master slave out and a master slave in. So what they do, master slave out takes out the communication from the Arduino, master slave in returns the communication back to the Arduino. So for the serial clock and the serial data, enables whatever you have interface to do the programming. So if you check on your kits, this is what you have. It's a blue PCB board. Some others call it circuit board. Others will call it motherboard. So in your container, you're going to find a USB micro B port to computer. It's a 7 to 12 volts input, which is provided. So from D15 to D0, it's also a digital input and digital output. And from 5 volts to the analog pin AO, all these are power points to power interface items. We are going to check on the items which we really interface, what we are interfacing. So, Arduino IDE, it has a software whereby you manage everything through the software. The software has libraries, has all the tools that you need to interface all the items, and it's very easy to use. So whenever you open Arduino IDE software, this is what you come across. You'll find files, edit, sketch, tools, and help. So file, you'll have a provision to save all the coding that you've done, and you can also edit the sketch. Sketch is what you've been writing. Whatever is not saved, it's a sketch. Whatever is not provided as a code is just a sketch. And then the tools, when you open the tools, you are going to find the library, the board information, what you're working with. It's very easy to use. And then help, you can type any crisis that comes on your way while using this board. Arduino, software, I just provided what's that. So we are going to make a Arduino data logger. What is Arduino data logger? So Arduino data logger comprises of interfacing the micro SD card module with Arduino micro SD card. It's more of a slot that you use in your local sensors to insert or to put an SD card. You are going to find in your containers something similar like this. You can zoom in the camera. This is an SD module card. So SD module, you're going to find them in almost majority of the local sensors, about 75%. Those who are not using a SD module card, they're using cloud to send data, which is also equivalent to ESP8266. And Purple Layer and other sensors are using ESP12 and ESP32. So these are, when you check on that component, you're going to find these parts. The VCC. The VCC is the main power source for the micro SD. It has a GNAD, which is a grounding. It has a MISO, master slave out. MOSI, which is a master slave in. SCK, which is a serial clock, whereby you can integrate the RTC using it. There's the CS, which is very key. Very, very key. Whenever you have a sensor and it's not working in storing data, go and check the CS, which is a chip select pin. It's a control. What it does, it controls the slave devices. So it carries the entire, it returns the entire program back to the sensor. So this is a complete connection. This is a circuit diagram. I don't know if everyone can see clearly. I'll share the slide with everyone. This provision, you can see it is only being used twice. Reason being is to power the Arduino and to do the grounding to return the power back to the board. And these are the communications on the board interfacing micro SD module with Arduino. So most cases you're going to find in the field, you're going to find PCB boards which are not written the meaning. Most cases they use abbreviations. You're going to see 3 volts, there's CS, there's MOSI, CLK, MISO, and grounding. So most cases you'll find a very small slight difference on one module to another. BM280, you'll find it has more pins than SD module. So this part is how you put together, how you link together. We have cable which has been provided inside your containers. This is whereby you can use these cables to link. You can try linking whatever you have there to try and link the SD module card to the Arduino. So this is the match that you should get. This is the VCC module to the 5 volts. This is the grounding to the Arduino. This is the CS, and the chip select to digital 10. This is the MOSI to 11. This is the MISO to digital 12, and the CSK to digital pin 13.